This is a tutorial for the Detail Threads tool you can find in my Cloth Sewing Toolbox, available on Gumroad and BlenderMarket. It allows to convert all the stitched curves created by tools like curve details, seam details, stitch details, and edge details, and even curve you can manually create, to fully detailed threads with different ply count, fibers, and so on. So once you've added the asset pack to the file path of the asset browser, I recommend to use the link import method so you can more easily update the asset pack with new versions and have everything updating accordingly. Then on your mesh, you can just drag in your detailed thread node group. Now the first thing I want to talk about is that this can create a huge amount of geometry, so make sure not to have any subdivision surface after it without ensuring that it doesn't create too many geometry first. Now we have a bunch of settings, but how about everything in this tool is organized with the notion of LOD, or level of details, like in video games. And this enables to really easily set the level of detail of the threads, either for the viewport or at render time. And basically the three available level of details are level 2, which is just a single fiber cross section. Level 1, if you have for example 3 plies, your fiber will be divided into 3 plies, but at level 0, each of those 3 plies will be able to be made up of a huge amount of sub-fibers. And in any of those 3 levels of details, you can also add flyaway fibers to make everything more realistic. So now let's get on with the settings. So the first one after the setting of the LOD is thread attribute. By default it is set to true, so that means that it will convert all the curves available on your object into detailed threads, but if you want to select a specific set of curves, you can select the corresponding attribute. So in this case, the attribute that is output by my stitch details modifier for the stitches is just called stitches, so I can set it right here. And this way, if you have different modifiers with different output attribute names, you can set up different types of details to different top stitches curves. The two next settings allow to change the resolution of the curve before converting everything to meshes. So first we can subdivide everything if needed. So for example, if I lower the resample unit stitch of the modifier creating the stitches to a value like 8 for example, I can still subdivide everything later in this modifier. Then we can also convert everything to a NURBS curve, which is a different way of evaluating the curve inside Blender. And this basically automatically increases the resolution of the curve by a huge amount because it adds way more interpolation points. So you might want to be careful with these settings, but it can be useful to visually increase the resolution of the curve even if you have a low resample unit stitch in the base generating modifier. And the next parameter allows to set the general radius of the thread. So right here it's way too high, so I can lower it quite a bit, so maybe 0.25 millimeters. You can also see in LOD2 that it is correctly updating the radius of the thread even when it is a single curve. Next we have the thread resolution, which is just the main resolution of the thread when we are in LOD2. So by default it is set to 8, but if you just want to have a thread which is visible from afar, you can set it to 3, so it will be way less expensive to compute. But as you can see, this doesn't affect other LODs because it is just for the main thread. Next we can set the material of the threads. Next we have the general twist speed, and this is about the number of turns per centimeter. So if we set it to 1, we can see that all the threads are twisting. You can also set it to a negative value. And here, if you don't see the effect of it, you may not have a high enough resolution, or if the twist speed is too high, or if the twist speed is too high, you won't be able to see the twisting anymore, because a full turn of twisting between two adjacent edges will be equivalent to no twisting at all. Then we have two parameters to trim the start or end of the curves if needed, and a viewport decimation parameter, which is mainly visible for the flyaway fibers. Next we have a toggle value to fill the caps of the generated curves, so this is only visible at the end of the curves. The next setting, set auto handles, only works on basic curve which you are turning into threads, and by default the curve stitches generated by my asset pack are just poly curves, but in this case, if I set my tool to a curve with a few subdivision level to see the twisting, you can see that at some points it gets a bit weird. And here by setting the auto handles, it can fix the visual aspect of it. Next we can go into the Ply settings. So here I am at a viewport LOD of 0, but let's get back to 1 so we can see the first setting regarding the plies. So by default it's set to 3 ply, but you can set any number of it you want, and the default resolution is 4, but here you can just change the resolution of the profile curve, which is generating those threads as well. You can also change the twist speed of the ply themselves to be independent for the general twist speed, so you can have the general fibers twisting in one direction but the fiber in the other direction, and that's about it for the ply setting. Then you can move on to the fiber settings, which are only visible at LOD 0, which is max detail, and here the first thing we can do is set a way lower fiber radius. Let me just change the start clipping of the viewport. So by default we only have 4 subfibers by ply. But if I set it to a higher value, so for example 42, you can see that all the ply are made of really small fibers. For which you can also change the resolution, but usually if they are really small, you can keep a fiber resolution of 3. So as you can expect, at this point, when you have several fibers and subfibers, it can add really a huge number of faces to your mesh. So that's why I implemented the workflow of using level of details for our render and viewports. Because as you can see right now, this mesh has 2.5 million faces, but without this modifier, we are only at 980. So let's go back to a viewport LOD of 1, so you can have better performances for now. And let's have a look at the Flyaway settings. Here you need to understand how the fibers are instanced, and basically they are not instanced randomly along the faces of the generated thread, but they are only instanced on the points of the stitch curve, before the curve is turned into a mesh. Because this is the only way to have similar looking flyaway fibers regardless of the level of detail or the animation of the mesh and so on. This is a way that is way more stable than the other workflow. But the drawbacks are that instead of having to set a density value, you have to set a fixed count of fibers, and when your thread is low resolution, like for example with this Bezier curve which only has 2 points, if I add this modifier and a few flyaway fibers, they are only instanced on the end of the mesh. Let's just set the viewport decimation factor to 1, so you can see everything, and as you can see the fibers are only instanced on the end. But now that we know that, let's go back to our test object, change the viewport decimation again to 1, and let's add maybe 5000 flyaway fibers. So right now they are quite big, but of course we can change their radius to make them really small. As usual, you can also change their radius resolution, but again, if they are really small, you can almost always keep this at the value of 3, so it only has 3 faces on the side. Next, we have the general length of the flyaway fibers themselves, and the resolution on the length of the fibers. So here, if you want to have some freeze for the fibers, like is the case right here, you may want to have a higher resolution, but otherwise, if it doesn't matter, you can have a really small resolution, but as you can expect, those would be just straight lines. Then we also have a freeze factor, and this is based on the freeze hair curve, which is available by default inside Blender, and this gives a really nice natural look. The next parameter is the number of individual fibers we have. Right now, we only have one type of fiber, which is instant everywhere. The shape of it is just the same everywhere, but if we need more detail, we can change this by introducing more variations. So here, with the value of 2, we introduce a new type of fiber, and so on. And this is also an easy way to add way more variation if you need more details. If you need more specific curves, you can also set a custom collection of curves. So for example, if you need flyaway fibers which are twisting on itself, you can just add them by adding a basic curve and drawing a curve just like you want. Put this into a collection, and now you can use this in this modifier, just like that. And because it is a collection, you can also have any number of fiber in it as you want. The next parameter, Flyaway Align, tries to align the fibers more or less along the generating curve. So when it is set to 1, the fibers are trying to follow the tangent of the curve which is generating them, but when it is set to 0, they might stick out way more outside of the mesh. And the final vector parameter is just some base value for the random rotation, which allows to change the look of everything really easily around the 3 axes of each individual fiber. And as you can see right now, if I change the viewport decimation, I change the number of fibers which are instanced. And the final parameter is the UV of the threads, and this allows to add precise shading to the threads. So let's create a new material for the thread, assign it in the modifier, move on to the render view, and let's bring in an attribute using the UV map created by this tool. So here, as in the other tool of the toolbox, it is not exactly a UV map with only X and Y coordinates, but I also store some data on the Z-axis, which is why we have to use the attribute node instead of the UV map node. But generally the first 2 coordinates are just the UV map of the curve, which can be used to drive a noise value like in this case, to improve the detail of the thread without having to use subfibers and so on. But the last value on the z-axis is actually an index for the different ply of the fiber. So in this case, I have 3 ply. So if I take this value, divide it by 3, and put this into a color ramp, I can actually assign a different color to each thread. Which can again give really nice control to the shading of everything. And here it can look really nice if you also use some transmission or some subsurface scattering with a really low radius value. So that's about it for this tool. I hope you found this video interesting. If you have any more questions about this or regarding the whole asset pack, make sure to leave them in the comment so I can improve the documentation and the toolbox in the future. Thank you for watching and see you next time.